the cell phone to search the information. So do you have any question? So clear?
Sir, how many chapters included? 3 chapters?
We do not include this chapter. Okay. So this chapter won't be included. So now we will move to AC-AC converter. So if you need to design AC to AC converter, how can you design it? So in general, we use 6 dial. And then we put huge capacitor. And then we design inverter. And then we have motor. So we call this is DC link voltage. And we call this is inverter. So inverter convert the DC into 3-phase AC. And we call this is rectifier. Which convert 3-phase AC into DC. So this is typically structure for AC to AC conversion. So how about the voltage? The voltage, if we have VAN, it is like this. How about the input current? We use diode, so the current is like this. So this is IA. So how about the input power factor? So the input power factor, you have to convert this to the AC current, and you compute the power factor could be 0.4. So do you think that this is good? If you have power factor 0.4, if you have this waveform, and this could be 200 ampere, because huge drive system. Do you like this circuit? You say no, it is not good. So how can I improve the power factor? If you want to improve your power factor, you have to follow the principle. So we have capacitor, we have inverter, we have motor. So first, you need to boost your voltage. So before, here could be 300 volt. But now you need a PFC, right? You have to increase your voltage. So it could be 600 volt, become double. If you need to do PFC, you cannot use diode, because diode only go one direction, right? So if you need a power factor correction, what do you need? You need to control AC current. If you need to control AC current, then you have to redesign the input side. So you have to put here. So you have to use IGBT to control it. So you have input voltage here. But you need a 6 switch, not 6 dial. So you need a 6 switch. So the switch could be like this. So some people propose we need to do this. Then we can control the voltage. So we have 3-phase voltage. So for example, we have A phase voltage here. then we can regulate the current. If we want to regulate the current, we need inductor here. So we have to put inductor here. Then we can regulate the current. Then we can create the current waveform like this. So it is sinusoid. We do the current regulation. Then we can create this input current. Then we need 6 switch, 6 IGBT. Here is 6 IGBT. So here output current is sinusoid. We can control sinusoid current. Here we also can control sinusoid current. So our current could be like this. And here we can get current like this. And here we can get current like this. So it is good. We can do unity power factor. Then we call this is inverter. Here is DC link. Here is inverter. How about this one? This is PFC, right? 3-phase PFC. So the PFC can create sinusoidal voltage, sinusoidal current, but we need control. We need a sensor, right? So if you want to control this one and control this one, then you can see this is like a mirror. The mirror has 2 sides. Each side has 6 IGBT. Each side has inductor. So they are equal. Then how about the price? What is the price? Before, here is white stage, right? Here could be 70,000. And how about this one? The same, right? Totally the same. So this is also 70,000. So how about your price? Become double, right? Because you need 1, 2, 1, 2, 1, 2, 6 switch, 1, 2, 1, 2, 1, 2, 6 switch, and here you need a DSP. Here you need the same another DSP. Here you need a Hall sensor. Here you need a Hall sensor. Everything is the same. So what is your price? Double. So do you like to do this? So if you buy an inverter, you buy the traditional one, it is 70,000. You buy a new type with PFC, it become 140,000. Become twice. The price become twice. Then nobody can afford it, right? Nobody can afford it. Then can you pass the law to ask every driver should follow unity power factor, should follow the regulation. Once you pass it, everybody should be followed. Then every price becomes double. Then nobody can do it because the industry will against it. So if you check PFC for a computer, for cell phone, for charge, it is perfect because well developed and everybody accept. But motor drive, they spend more energy, right? Their current become larger. They become more important. But why don't we pass a law to regulate the power factor? Nobody dare to do it. Because once you do it, everybody should follow. If everybody follow, then the price becomes double. So nobody want to do it. So until now, we don't have any regulation for this kind of drive system. For elevator, we only use rectifier. So if we use rectifier, so what is the current? Maybe 400 ampere, but discontinuous. Then it influences everywhere. right? So it is not good, but we have no idea how to solve this problem. So some people say, can we reduce 2 stages into 1 stage? So this is a fundamental idea. If we can remove the 2 stages, we only use 1 stage, then the idea is like this. So we have 3 phases. So we have 3 phases, and then we have load here. Then we use 9 switch. So then we have AC to AC, not AC to DC, and DC to AC. We have AC to AC. Then the idea is good, right? So if you have power conversion, do you like 2-stage power conversion, or do you like 1-stage power conversion? The more stage, then you have efficiency. Efficiency is eta 1 multiplied by eta 2, right? If this is 0.95, this is 0.9, then the total is 0.95 multiplied by 0.9 could be 0.85. So the efficiency is reduced. The loss is increased. The price is increased. So do you need a single stage or 2-stage AC-AC converter? 1 stage, right? So the idea should be 1 stage. So we can say this is single stage AC-AC converter. So the idea is very simple, and it is reasonable. We do not like 2-stage. We prefer 1 stage. And we can get better efficiency. We can get simplified topology. And the price should be reduced. But why in the market it is very hard to find any AC to AC converter? Nobody uses it. Why? Everybody just prefer this one. Nobody like this because too expensive, and nobody like this. So we still prefer AC to DC rectifier, and then DC link voltage, and then inverter. We still use this. Why? So we will discuss this issue from the basic principle. This is not good because power factor is not good because it is 2-stage. If you want to improve power factor, you should use this. But nobody uses this because it becomes double. If you need 1 stage, you should use this. But nobody uses this because if you learn PWM, what is PWM? You say, if I know DC, I can convert to AC. If I know DC, I can convert to DC. How about AC to AC? We didn't learn, right? I don't know what happened. So this is the challenge because the input is sinusoidal. The output is not sinusoidal. This is 60 Hertz. 220 volt. This could be 110, but 120 Hertz. So this is time variant. This is time variant. How about the switch? I don't know. I don't know how to change the switching pattern, right? So this become a new trend, and some people try to propose a new idea to solve this problem. So we call this is AC to AC converter. So now we will focus on AC to AC converter. So if you think about this issue, what can you do? You can say, or I can use the thyristor. So I can control the phase angle. So this is for A phase, this is for B phase, this is for C phase. And if this structure, this is plus, this is minus. If this structure, this is plus, this is minus. So I can have plus or minus. So I can have AC, right? This handle plus, this handle minus. So this for A phase, this for B phase, this for C phase. Then everything could be fine. So we call this is cycle converter. What is cycle? So we call this is one cycle. Cycle means what? Frequency, right? Frequency. We change the frequency. So if you need to change the voltage, what can you use? You can use transformer. So transformer change AC to AC voltage. Do you think a transformer can change AC to AC frequency? Input 60 Hz, output 120 Hz. Can you use a transformer to do this? The answer is no. Transformer only convert but voltage, not frequency. If you want to convert frequency, what can you use? You need to change cycle. Then we call it is cycle converter. So maybe 100 years ago, people proposed this idea. They say, I have a motor here, I have 3 phase here, so I use how many SCR? 1, 2, 3, 4, 5, 6. This is 12. This is 12. This is 12. Totally 12 multiplied by 3. 3, 6 SCR. Huge, right? Huge. Very huge. So then I can control 3 phase output voltage and its frequency. Then I can change the speed of the motor. So we call this is cycle. We change the cycle of the output. We call it is a cycle converter. So if you go to a shop and say, I need a cycle converter. I need to change 60 Hz to 1 Hz to 60 Hz. I want to change the cycle. Can you give me a cycle converter? Can you buy a cycle converter? And no. The officer or the clerk said, I have no idea what are you talking about. Because no this kind of product. So this is 200 years ago. So people proposed this idea and they use for mining. So they need a core. They need a car to go into the channel to get the core and move out. So we call this is cycle converter. They need to change the speed of the car. So they change the frequency. We call it is cycle converter. So if you check the paper, it could be 200 years ago. So what can we do? We change the delay angle. So delay angle is minus 90 plus omega 0 t. So we can compute the time interval, or we can change the delay angle from 90 degree minus omega 0 t. Both are okay. Then we can have the time interval like this. Then what is the waveform? So we can draw the waveform. So we can draw the waveform like this. So we change the delay angle. First 90, 70, 50, 30, 10, minus 10, minus 30, minus 50, minus 70, minus 90, minus 110. So minus means delay. So delay the zero closing. This is advance the zero closing. So this is zero closing. I advance 50 degree. Then we can see the waveform is like this. If the waveform is like this, what is the peak value near here? So we have sinusoidal peak. And then half plus half minus then become 0, right? And here, half plus half minus become 0. So it is a kind of waveform like this. So the fundamental is sinusoidal, right? How about its harmonics? Harmonics is very huge. So you can see the delay angle, 90, 70, 50, 30, 10, minus 10, minus 30, minus 50, minus 70, minus 90, minus 110. So my question is, can you push the output more than 60 Hertz? You only can reduce the frequency, right? Can you increase the frequency for more than 60 Hertz? But for one correction, you only have one opportunity to control the delay angle, right? So you have no opportunity to large than 60 Hertz. You only can reduce your frequency, but you cannot increase your frequency. So this is one disadvantage. The second disadvantage is the harmonics is very huge. If I use my eyes, I found the fundamental is not very good. The harmonics is too huge. So then we can do some analyze. So another way is we change the delay angle from minus to plus. We also can get a sinusoidal waveform. Here, the peak is here because almost largest. Then we have plus and a minus equal. Then this is 0. This is 0. So the waveform is like this. So we can get a sinusoidal waveform. So we have two ways to generate the output voltage. So this is a real cycle converter. So you can see the waveform is like this. We can reduce the frequency, waveform like this. So we can see this is 3-phase load. And each phase, how many devices do we use? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 12, 12, 12. Total how many? 36. This is for A phase. This is for B phase. This is for C phase. And the output is like this. You can see the output fundamental should be sine wave. So we call this is 3-phase 6-pulse cycle converter with isolated phase load. So they use in mining industry. So it is AC to AC. But finally people found that the performance is not good and that the cost is very high. Then they say this is not a good idea. So now if you go to IEEE Express, you key in cycle converter, then you only get a few papers because this is out of date. We call this is dead technology. So now people propose another way. They prefer use matrix converter. So what is matrix converter? What is matrix? If we learn matrix, we know it is A11, A12, A13, A21, A22, A23, A31, A32, A33. So we call this is 3 by 3 square matrix, right? We call this is matrix. So this is like this. We have H11, H21, H31, H12, H22, H32, H13, H23, H33. So totally 9 switch. So this one determine the A phase output. This one determine the B phase output. This one determine the C phase output. For this line, we say H11 plus H21 plus H31 have to equal to 1. If they more than 1, then means short circuit. If the result is 0, and that means the I1 has no loop, open circuit. So you can say for each line, if and only if one switch is turned on, and the input is voltage source, the output is current sink. So how about this voltage? This voltage is equal to Vin multiplied by H11 plus Vin2 multiplied by H21 plus Vin3 multiplied by H31. So we can write down H multiplied by Vi, right? How about this one? This is Vin1, H12, Vin2, H22, Vin3, H32. So this is V2. This is V3, H13 Vin, H23 Vin2, H33 Vin3. So we can say V out is H multiplied by Vi. And then the current, the power is equal. So VO is 3 by 1. So we can say VO, so we have VO1, VO2, VO3. So this is 3 by 1. How about IO transpose? IO transpose, IO1, IO2, IO3. So it is like this. Then we call this is IO transpose multiplied by VO. This is 3 by 1. This is 1 by 3. So it becomes 1 by 1. So this is output power. So output power is equal to VO1 IO1 plus VO2 IO2 plus VO3 IO3. So this is output power. And this is input power. So input power equal to output power because the switch is lossless, right? So input power equal to output power. So after some math, we can calculate the input current is output current multiplied by H transpose. So this is output voltage is input voltage multiplied by H. But input current is dependent on output current. So output current is independent. It is constant current. So HT multiplied by IO equal to II. So input current rely on output current and the switching function. Output voltage rely on input voltage and the switching function. So we discussed this before. So we can have some basic rule. So now the question is, then how can I determine the switching type? So how many unknown parameters do we need? So if you want to solve this problem, how many unknown? You know output current, you know input voltage, but you don't know the switch, right? So how many unknown? 1, 2, 3, 4, 5, 6, right? 7, 8, 9. So you have 9 unknown. You have 9 unknown. But you only know output current. And you know input voltage. Can you solve the 9 unknown parameters? So how many equations do you have? 3 equations. How many unknown do you have? 9 unknown. Can you solve this equation? So you have 9 unknown. But you have 3 equations. Can you solve one unique solution? The answer is no. You have no opportunity. So you go to this problem, you tell your advisor, if I know I12, I2, I3, if I know Vin1, Vin2, Vin3, I want to find the 9 switch on or off. Then after you go back, you found there is no solution. So your idea just dead. So you cannot solve the problem. So what can you do? You have to go back and sleep. So one student, he want to use this topic for his PhD. So his advisor asked him to find the 9 switch. And finally, he proposed some idea. He said, for each line, I have 3 switches. The first switch turn on T1. The second switch turn on T2. The third switch turn on T3. Then T1, T2, T3 become one sequence. But for A line, B line, and the C line, the T sequence is always 1 millisecond, right? So I have 3 lines. So T1 plus T2 plus T3 equal to T sequence. This one, the same, T1 plus T2 plus T3, T sequence. T1 plus T2 plus T3, T sequence. So we have output 1. Output 1 is V in 1 multiplied by the first switch. V in 2 multiplied by the second switch. V in 3 multiplied by the third switch. So we have here, we have V in 1, V in 2, V in 3. So this voltage equal to this voltage multiplied by this switch, plus this voltage multiplied by this switch, plus this voltage multiplied by this switch. So we can get first equation. And the second equation is here. This voltage multiplied by this switch, this voltage multiplied by this switch, this voltage multiplied by this switch, and the summation becomes VO2. And then the third line, this voltage multiplied by this switch, this voltage multiplied by this switch, this voltage multiplied by this switch, we can obtain VO3. So how many equations can we have? 3 equations, right? 3 equations. How many are known? We call this is T1, T2, T3. So this is T1, T2, T3. Then we call this is T1, T2, T3. Then we call this is T1, T2, T3. So how many are known? 3 are known, right? How many equations? 3 equations. So 3 unknown, 3 equations. Can we get a unity solution? Yes. So the student is very smart. He said we put T1, T2, T3, T1, T2, T3, T1, T2, T3. Then we can shift 120 degrees. Then we have 3 parameters, T1, T2, T3, to be solved. And we have 3 equations. So we can get one solution. Then I can grade you at tomorrow. Do you like to do this? Yes. So it is very hopeful. So he go back to solve this math. So he tried to find T1, T2, T3. So we have this equation, 3 equations, and VO1. 3 equations, VO2. 3 equations, VO3. We try to find T1, T2, T3. So if you learn engineering math, so you have 3 by 3. And you have to solve T1, T2, T3. And you have VO1, VO2, VO3. So how can I solve this equation? So you can say T1, T2, T3, we can move this to here. If we move to here, it is A inverse. Then VO1, VO2, VO3. We call this is matrix, right? So we just move to the right side. We use inverse. So if you try to find the inverse, then first you have to determine the A, right? If you want to find the inverse, first one, you have to determine the A. So he determine the A, it becomes 0. If determine the A is 0, then what is it inverse? No inverse, right? So if you learn math, you know, if you want to find the A inverse, the condition is determine the A cannot be 0. But now determine the A becomes 0. If determine the A becomes 0, what does this mean? Means the 3 equation is redundant. Only 2 equation is useful. Another depends on the first 2 equations. So in fact, you only have 2 equations, but you have 3 unknown, then you have no answer. So finally, he said this is linearly dependent. So we have 3 dimensions, but we only have 2 rank, because the other equation is rely on the combination of equation 1 and equation 2. So it is linearly dependent. If this is linearly dependent, we have no solution. So his dream was broken. He cannot graduate. So he go back to sleep again. And finally, he found the solution. What is his solution? He said, I have 3 unknown, T1 plus T2 plus T3 equal to T seconds. So now T seconds is 1 millisecond. So I need 1 kilohertz switching. So if I know T1 and T2, then I can compute T3 is T seconds minus T1 minus T2. So how many unknown do I have? 2. So I have 2 equations. I have 2 unknown. Can I solve the equation? Yes. So he is very smart. So he thinks I don't need 3 unknown. I only need 2 unknown. But I only have 2 equations. So I can get unique solution. Then finally, he found the solution. So he found T1 is here, T2 is here, T3 is here. So what is T1? It is equal to 1/3 of T seconds plus 2/3. This is output amplitude. This is input amplitude. Output could be 110. Input is 220. This is cosine. This is output frequency. This is input frequency. This is time from 0 to 0.5 millisecond, 1 millisecond, 1.5 millisecond increase. This is T sequence. You can design T sequence at 1 millisecond. So you can compute the T1, T2, T3. Then you can send the time interval into the switch. Then you finish the matrix converter. So he feel very, very happy. So he found he can use a DSP to compute T1, T2, T3, and then he put T1, T2, T3, T1, T2, T3, and T1, T2, T3. So he can determine the required switching time. Then he can graduate. So he can prove the output current is here, and the input current is here. Then finally, he used this particle to graduate. And this is the first time the AC-AC converter can decide its switching sequence. So this is very useful. Then, what is the power factor? So if you use this way, what is your power factor? Can you use the switching pattern to improve to get unique power factor 1.0? The answer is yes. So we can change the switching frequency, and finally we can obtain 1.0 unity power factor. Then what do you mean? You mean my matrix converter is equal to this circle because I can obtain power factor correction, right? So then this is good because I use 9 switch. But before, how many switch do you use? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You use 12 switch. How about this one? 9 switch, right? This is one thing. Another thing is you use a huge capacitor, right? Here. How about this one? This one only. How many capacitors do you use? 0, right? So which one is better? This one or this one? You say this one is better. If this one is better, why people don't use it? Why? It can save 3 switch. It can save huge capacitor. It can automatically obtain unity power factor. So it is single stage, high efficiency. So it provides so many advantages, but why people don't use it? So anyone can answer this question? So we will discuss this next week, not next week, the week after next week. So next week we will have the midterm exam. So I will see you next week.